Welcome everyone. My name is Salman Salah Albuflasa. I'm a fire and safety engineer. And before we begin, this presentation is my own personal work and for educational and awareness purposes. It does not represent or is not connected to any organization or entity. Fire safety is one of those fields where everyone thinks they understand it until they are standing in front of a real project, a real inspection, or a real submittal review, and then realizing they actually do not understand it. And this is the reality of an industry where the knowledge gap between what people are taught and what the field actually requires is wider than most people want to admit. And this presentation exists to close that gap in a specific field of fire protection, especially for new engineers and anyone just getting into this field. Because as a fire professional, you should know this. Whether you're a consultant, a contractor, or an inspector, this should be the foundation of your work. We're going to start from the beginning, how fire actually behaves, which will lead us to how materials are being tested and what the results mean. And then we'll build up from that. What are standards? What are certifications? And what are the documents behind them? And by the end of this presentation, you'll know how to look at any fire safety product, any certificate, any report, and understand what it means. You do not need to be an expert to be here. This is a foundational lecture, and you just need to be someone who decided today is the day you actually learn it. So let us begin. This presentation is about fire protection, standards, testing, and certification. This is Ministry of Interior Decree number 111 for the year 2025. This is what made the Bahrain Fire and Life Safety Code official and legally binding. Two articles, both matter. Article 1 states that this code is effective as of the 2nd of January. And Article 2 terminates the old Fire Safety Code of Bahrain. And like most countries in the region, Bahrain does not write every requirement from scratch. We reference and adopt international standards, which are mostly from NFPA, the National Fire Protection Association, and other safety standards, but tailored to Bahrain's specific content, its climate, its building types, and its occupancies, and its risk profile. So when you work under this code, you are not just dealing with one document, you are dealing with every standard it references. So this is how this presentation is structured. It's divided into 6 parts. Part 1 is the fundamentals. Before anything else, you need to understand how fire protection is built. Active systems, passive systems, fire prevention, the permit system, and why testing is not optional. And part 2 is fire testing, what actually happens when a material or product goes into a testing chamber, reaction to fire, resistance to fire, the instruments used, and the international standard behind every test result you will ever read. And part 3 takes everything from part 1 and 2 and integrates them into the product itself. For example, the sprinklers, the fire doors, the cladding, the fire pumps, real products and the real requirements. And part 4 is test reports. This is where most people have gaps. You will learn how to read a fire test report and what makes it valid and what does it require, and certain red flags in the test reports. And part 5 is review and compliance, or basically certification, the global system behind every mark in the product, who verifies the laboratories, who audits the factories, and how your listing from United States ends up accepted in Bahrain or in the Middle East. And part 6 is summary and takeaway. As you can see, each part builds on the one before, and by the end, it would all connect. Before we get into testing and products, you need to understand how fire protection is structured, because everything in this field derives from this. Active fire protection and passive fire protection. And if you are here in this lecture about testing and certification, I'm sure you already know what this is. But if not, the concept is actually simpler than most people think. Starting with passive, think of a medieval castle. Stone walls, thick doors, compartment rooms. And if fire broke out in one wing, the walls contain it. Nobody activates anything, nothing needs power. This is what's meant by passive fire protection. It's built into the structure itself. Picture a wall holding back an invading army with no ammunition used, no power needed, and no one giving orders. It's just there doing its job. This is the passive fire protection. And an example of passive fire protection are fire-rated walls, fire-rated doors, dampers, and fire stoppers. So no switches, no activations, even with no electricity, no people, and no one is watching, it will be passively working. Now for the active fire protection, think of a modern hospital. The moment a fire starts, detector triggers, sprinkler initiate, alarm notify the whole building, smoke control fans start up diluting the smoke from the area. All of that require power, commissioning, inspection, testing, and maintenance. It's the intervention layer. The sprinkler, fire alarms, fire pumps, standpipe systems, smoke control, clean agents, kitchen suppression systems, detect fire, suppress it, alert occupants, and manage the smoke environment. And the main thing is, both are always needed. Always. A building with perfect sprinklers by non-tested firewalls is not a safe building. And a building with beautiful fire-rated construction but no detection or suppression system is equally incomplete. Let me give you some definitions that you need to know. Some might seem obvious. A supplier or distributor is an establishment that is listed and permitted by the local authority, for example, General Directorate of Civil Defense, in order to sell fire and life safety systems, equipment, materials, along with its accessories and fit-out. And it must hold a distribution agreement with the manufacturer if it imports from outside. A testing laboratory is an accredited body that conducts fire performance tests, reaction to fire, fire propagation, and fire resistance, but the keyword is accredited. We'll get into that later. A conformity certification body is different from a testing lab. This is the body that awards international safety certificate. It doesn't just test a specimen, it verifies conformity, monitors quality over time, and audits through a surveillance program. For example, UL, FM, LPCB. And here where it gets confusing, the cross-listing and the multiple listing. This is the part that trips a lot of people up. So, we'll simplify it with an example. Think of McDonald's. Every McDonald's in every country looks the same from outside, but inside, different owner, different management, a different city. But when we walk in, the burger tastes the same. The Big Mac in Bahrain, the Big Mac in Dubai, the Big Mac in the United States of America is the same. Why is that? Because every single franchise went through the same process, same standards, same ingredients, same training, same audit. But the owner is different. But what they produce is verified to be identical. That's cross-listing. What about multiple listing? Now imagine someone open up a place, prints McDonald's sign, puts it on the door, and starts selling burgers. Same logo, same colors, but nobody audited them. Nobody checked their kitchen, nobody verified anything. You have no idea what's actually in that burger. That's multiple listing. A brand name attached to someone else's verification or certification without going through any verification on their own. It's not a factory, but a brand claiming to meet the same quality and standards as the primary manufacturer. Let's take another example in order to simplify it. Let's say Navco, a manufacturer based in Dubai, one of the largest fire protection manufacturers in the region. Their fire pumps carry UL, FM, listing and approval marks. Both verified, both active, both earned through full testing, factory audits and surveillance. Now, Navco opens a manufacturing facility in Bahrain. Same company, same brand, but different factory, different location. They cannot assume that Dubai UL listing automatically transfers. No. UL send quality auditors to Bahrain. They verify manufacturing process, raw materials, quality controls, and production consistency. And then UL confirm that Bahrain output is identical in fire performance to the Dubai certified product. Only then the Bahrain facility is cross-listed under the same certification. Now, a separate trading company here in Bahrain, different name, different owner, no manufacturing facility, takes Navco certificate number and attaches it to their own product documentation. Same mark, same numbers, looks identical on paper. But what was never done was no factory audit, no supply chain check, no product verification, and no surveillance program. So that certificate belongs to Navco and not to them. The product behind it is completely unverified. A certificate that belonged to someone else presented as their own. The permit system. Every stage exists for a specific reason. Let me give you a real example of each and every one of them, so it can be clear for everyone. Starting with architecture or the life safety layouts. Fire safety does not start with the fire sprinkler system. It starts with the layout. The way a building is designed determines how fire spreads, how smoke travels, and how people get out. If these are wrong in the architecture, no amount of sprinklers or alarm will fix it. It has to be right before anything else is designed. So addressing fire protection at this stage ensures egress, compartmentation, and suppression systems all fit naturally within the architecture itself. Leave anything out here and you push the design towards a layout that later conflicts with code requirements. And unfortunately, we have an example, the Coconut Grove fire. The club had expanded through a series of unpermitted extensions with no architecture approval or layouts. The basement lounge had one public exit, and it was 1.2 meters wide staircase. And the main entrance was a single revolving door that jammed immediately as people rushed toward it. Other exits had been bricked or welded shut, and some doors opened inward. This is definitely useless when the crowd were pushing against them. And the club was heavily decorated with flammable materials, paper palm trees, gold ceilings, so the moment fire touched them, it spread across the entire space in seconds. And that building was packed well beyond its capacity. And this is exactly why occupant load calculation exists today, to prevent more people being inside than the exits can handle. And the people that died that day, not because the fire was not in control, and not because the fire was uncontrollable, because the architecture decisions, the layouts, the exit, the materials, the occupant load was never properly viewed. So basically the building turned against them. And this is one of the most important things to understand about fire safety codes. Most of them are not written from theory, they were written from tragedy. Every requirement you see today in NFPA 101, every exit width, every door swing direction, every occupant load calculation has a fire behind it that proved why it was needed. And this is an example of why architecture or life safety review exists to prevent today, because we do not wait for the next tragedy to enforce what we already know. But remember, it's your family, it's older people, it's mothers, it's grandparents, and it's kids or people with disability who will be there. And codes and standards are always designing not for the average human being, but for the weakest person out there. And anyways, moving ahead to MEP design, sprinkler layouts, the fire alarm system, fire pump specifications, and smoke control, all of it must be reviewed and approved before a single pipe is installed. Because a sprinkler system designed to the wrong standard or the wrong spacing will not perform when it is needed. The review exists to catch those problems on paper when change is just a revision, not on site when it means tearing down everything from the building. And one of the most famous examples are the MGM Grand Hotel and Casino in Las Vegas. In 1980, a fire broke out and the fire started from an electrical fault in a restaurant in a casino floor. A small contained ignition point, the kind of fire sprinkler system would just extinguish within a second. But during construction in 1972, the owners installed sprinklers only in the absolute minimum areas required by the code. Definitely to save money. And back then the inspectors or the building inspectors got an exemption for the casino and restaurant spaces. The reasoning was those areas will be occupied 24 hours a day. So an employer or anyone there would notice the fire and use a portable fire extinguisher. They were relying on the human factor, unfortunately. And by November 1980, 8 years after the approval, that restaurant was no longer operating 24 hours a day. The fire broke out while the restaurant was completely closed and empty. And nobody was there to notice. Nobody was there to use an extinguisher, and the fire grew undetected until it was too late. Within 6 minutes, the entire casino floor was engulfed in flames, and also smoke traveled through the inside elevator shafts, the stairwells, and the air conditioning ducts straight to the upper floors. And 61 people died from floors from 19 through 26. People far from the fire. And the investigation concluded that if there were sprinklers that day, in that specific area, the fire would have been extinguished by 1 or 2 sprinkler heads, and we've never heard of this fire ever. And this is my point. We should never rely on the human factor in fire safety. People are not always there. A system that depends on someone being present to work is not a system. That's why we call it the fire suppression system, fire alarm system. We do not depend on the human factor in fire safety. And the MGM Gun Fire had significant effects on NFPA codes and standards, which basically increased requirements for automatic sprinkler systems in high-rise hotels and similar occupancies, and expanded requirements for smoke detectors and fire alarm systems, and enhanced means of egress rules, which basically means updated the requirements of NFPA 13, NFPA 72, NFPA 101, and the others. And this is the whole point of reviewing MAP designs today, to make sure what is on paper actually protects the people inside, before anyone has to prove it the other way, the hard way. And then we have the product conformity. What I say is the manufacturer catalog is not a proof. I can make one using Canva today, so it's not a claim. What proves the product actually works is testing against a recognized standard under controlled conditions by a accredited body with documented results. That tested and certified performance is what approved layout is built around. Every calculation, every spacing, every coverage area. So when you change the product, the whole system no longer performs as designed. Let's take an example of the Station nightclub fire. In the Station nightclub fire, there were many things wrong that day, but I want to focus on one thing specifically. The owners installed foam on the walls and ceilings just to reduce the sound from several complaints, and that foam was not flame resistant, never tested for reaction to fire, never certified as an interior finish. And then there was a concert and the use of the pyrotechnics inside. That pyrotechnic flames ignited the whole building. 100 people died, 230 were injured. And that building has been inspected twice in a few months before the fire. And they passed the inspection both times. That foam was against the code. He saw it but never flagged it, and nobody verified what was on that wall. Yes, it is approved by paper. The whole building is approved by paper, but a non-certified material in a building full of people, and it's burning exactly the way an uncertified product burns. Without limit, without control. And this is what the product conformity exists to prevent. And this takes us to inspection and permits. Basically, any engineer can walk through a building and verify what is installed exactly match the layout. You'll walk with the layout, you'll just match what is exactly on the ceiling and what's on the wall exactly as the layout. It doesn't take much effort, it doesn't take much experience. But a fire inspector does more than that, or should do more than that. The fire inspector has the eye to evaluate the premises of the hazard, the blocked exit, the flammable materials, the electrical issues, different fire loads. They test fire protection systems or oversee the testing, and they verify the product and they identify hazards that were never on any drawing, because they were never supposed to be there in the first place. The layout examiner might not see everything in the building, but the fire inspector sees everything in that building. He's the eye of the plan examiner. And what I mean is the foam in the Station nightclub was never on any drawing, never submitted for any approval, and installed quietly to solve a noise complaint, solving one issue and making a disaster in another way. And nobody caught it because the inspector checked exactly what he was checking, nothing more, nothing less, treating the fire safety as a checklist. Perhaps that building was actually approved and satisfactory, but the inspector who walked down that building twice had the authority, had the training and the obligation to flag that foam. He did not. So a signature on an inspection form is only worth something if the person who gave it actually looked at everything around it, not just the layout, everything in the building. And only then, when everything checks out, the certification of compliance should be issued. Why fire testing is mandatory? This is common sense. First of all, occupant survival. As we mentioned in the previous slides, time. And in a fire, time is the only currency that matters. Nothing else matters. A product that passes a fire test buys time. Time for alarm to sound, occupants to evacuate, and firefighters to intervene, or maybe a fire sprinkler to initiate. Everything is about time. So, Testing is the difference between a contained incident and a fatal one. It makes a difference. Reason 2, legal compliance. The product certification or the product conformity stage is not an optional phase. That is a legal prerequisite to obtaining the NOC or the final safety certificate. So that's not a recommendation, not best practice, and not optional. That's legal prerequisite requirement prior to that. That means any unlisted product found on site is not a technical deficiency. That is a violation of the legal consequences that will follow from that. Performance validation. Any manufacturer can print a datasheet. I can do one right now from Canva. I can put any number I want on it. There's nothing stopping me. But only an accredited laboratory can produce a valid test report, independently audited, verified results that is traceable, and can produce a valid fire testing report. See, a datasheet tells you what a manufacturer wants you to believe about their product, but a fire test tells you exactly what happened when exposed to fire according to the testing criteria, and these two are not the same documents. As we already know, fire damage causes millions in property loss, millions, along with insurance claims, legal liabilities, and the operational downtime, rebuilding the building, and redecorating, reinstalling the materials. This all costs money. As someone said, if you think safety is expensive, try an accident or try an incident. It will cost you more. So let's say if the building is insured, the insurance company questions are not too complicated to find any reason to void the policy. Seriously. So they might ask 1, 2 to 3 questions related to the building. For example, did the building had a valid safety certificate during the fire or during the time of the fire? And were the materials and products installed licensed by the civil defense or not? If you answer to any of these questions with a no, then the financial exposure will fall entirely on the building owner. Simple as that. And the fire doesn't have to be caused by the unlisted products. The products either contribute to the fire or fail to stop it. It's just the products had to be there to be taking the blame. That's it. Certification creates a traceable chain of responsibility. Every link is documented and every link can be verified from the manufacturer all the way to the end user and from the end user all the way back to the manufacturer. This is how we catch a counterfeit pump or fake detector back to its origin. Every link is documented and auditable. Finally, continuous improvement. Every fire safety standard that exists today was written in the aftermath of a real disaster. The MGM Grand Fire, the Coconut Grove, the Station Nightclub, and the Grenfell Tower, they all led to major changes and development or redevelopment of fire codes, regulations, and life safety standards. So, we can say that test data drives for better product design, all driven by real fire performance data. It tells us what worked, what failed, and why. It's like a feedback loop. And this is how we make sure that lesson never has to be learned again in your building. So what exactly is a standard? It's simple. A standard is a collection of agreed upon principles or requirements designed to maintain consistency, safety, and quality within a specific field and industry. But it should be agreed upon by the experts in that field. That's it. So when everyone builds, tests, and labels to the same standard, a product tested in one country means the same in another country. That shared language is the whole point. That's it. As simple as that. Are all standards the same? No. They fall into 3 main categories: the production design standards, evaluation and measurement standards, and communication and notation standards. So going to the first is related to how something is manufactured, designed, and drafted. The actual making of the product. In our field, let's say the specification for fire door, sprinklers, and pumps, for example. For example, NFPA 20 covers fire pump design, everything from the impaler materials to minimum flow rates and pressure requirements. So these standards are actually the DNA of the product. If you follow them, the thing you will build will be right. Evaluation and measurement standards. You built it, congratulations. Now you have to test it, analyze it, and verify it. So these standards make sure that a firewall tested in a lab in California must have the same result as the same wall tested here in Saudi Arabia. Same method, same criteria, and same results. As simple as that. Finally, the communication and notation standards. This set the uniform common language. The terms, the abbreviations, the symbols, the units. Take NFPA 170 as an example. This is exactly why fire exit signs look the same everywhere. And there's also the NFPA 704, the hazard diamond that you usually see on chemical stores, chemical storage tanks, and laboratories. The 4 colored quadrants numbers from 0 to 4, red, blue, yellow, white. No words needed. So let's say if a firefighter who's definitely trained on 1001 and 470 approach that building, he can read that diamond from far away. No words needed. He'll recognize that. That's uniform common language. How do I identify a standard? Because at first, they might look like random codes and numbers, but they all follow a predictable structure. Take any of these on the screen. It consists of 4 parts. First, the organization that produced the standard, often in abbreviated form, like ASTM, NFPA, UL, FM. Second, a report or a standard number, E84, 13, 300, 1371. And third, the year of the standard was approved or last revised, 26, 2025, edition for 2019, and 2020. And fourth, the title of the standard, for example, installation of sprinkler systems or approval standard for centrifugal fire pumps. Moving ahead, something that should sit with you every time you walk into a space with natural materials and amazing interior design. These 2 photographs of the same exact restaurant here in Bahrain. The first image shows the restaurant as it was built and operated. Natural wood ceiling beams, organic roof elements, exposed fabric and bamboo finishes, an authentic African cuisine with interior any interior designer would be proud of. Now let's look at the image on the right. The exact same spot, but now it's filled with smoke, twisted metal frames, burned out debris, bent metal, ash and coal instead of wooden and bamboos. This is the unfortunate reality of modern interior design. The more visually stunning a space becomes, the more we should ask ourselves what those materials will do in case of fire. And this restaurant is not an exceptional or unique case. Every year, in every type of occupancy, especially in restaurants, hotels, and entertainment venues that are filled with beautiful but untested decorative materials. The materials look incredible and the photos look amazing until something goes wrong. We're all familiar with the fire tetrahedron. It's actually Fire Safety 101. And we all know that safety doesn't come from assumptions. That's why we're going to start from the basics, because understanding what fire does in a building is the foundation of understanding why every fire test method exists. So, starting out with the ignition phase, it's as simple as the fire begins from a heat source. A heat source meets a material. The material's ignitability determines whether it catches it or not. Let's take an example. Let's say polyethylene and mineral wool. Polyethylene ignites at around 340 Celsius, but mineral wool does not ignite at any temperature encountered in normal building fire. But this is where the reaction to fire matters most. The test answers, how does this material behave when fire first meets it? After the incipient stage, the fire enters the growth stage. At this stage, it finds more fuel and oxygen to consume or burn. During this stage, the fire becomes larger and more intense. The heat release rate increases as the fire spread. If conditions continue to worsen, the growth stage might eventually become or lead to flashover. It's when all combustible materials in the compartment ignite simultaneously. How? I know some people might have an issue understanding the basic concept of flashover, but let's think of it this way. You know when you park your car on a hot day at noon at 12 p.m., those who live in GCC countries understand what I mean. And when you open the door, that wave of heat that instantly hits you, that's the room getting hot. Now imagine that keeps building up. The steering wheel getting hotter, the seats, the dashboard, everything is absorbing heat. And at some point, everything in that car would ignite at the same time. Not because of a flame touched anything, it's because the air itself became the ignition source. That's flashover. Pre-flashover, you can survive in that. Post-flashover, it's a different story. Anyways, in the fully developed phase, fire is fully established. Heat and flame intensely peak. Metal reaction to fire no longer matters, only fire resistance of the building. Remember the medieval castle example? That's it, walls, floors, doors. How much can they contain the fire in one compartment? How long they can maintain their integrity? This is the domain of fire resistance testing. I've been hinting at something from the beginning. Time. Because everything we do in fire safety comes down to one race. Can people get out before the building turns against them? And this graph is the clearest way to demonstrate that. Look at the top. We have the ignition, the growth, flashover, fully developed, and decay. And the vertical axis or the y-axis is how much heat, how much hazard is building up in the room. And the x-axis is simply time from the moment of ignition. And now we have two clocks, the asset and the arset. The asset is the available safe egress time. That's the time you have. It's how long until conditions in that space becomes untenable, until the smoke, the heat, and the toxic fumes or the toxic gas cross the line where a person can no longer survive or escape. You can see the line at the top, the untenable threshold. It's right around here, with these two lines cross. Asset is driven by ignition and growth phase, and it effectively runs out at flashover. Once you hit flashover, the time you have is gone. Remember when I said before flashover you can survive, post flashover it's a different story? That's it. Asset runs out at exactly flashover phase. The second clock is arset, the required safe egress time. That's the time we need, and it's made of three pieces. Detection phase, how long before the alarm before notices the fire. Pre-movement, the hesitation where people finish what they're doing, look around, decide if it's real or not. And then travel, actually moving to the exit. And these three together, that's how long evacuation really takes. So here's the whole game. In one sentence, as long as the time you have is greater than the time you need, asset bigger than arset, people get out. The gap between them is your margin of safety. The moment that flips, people don't make it. And now you might wonder, why does this belong in a presentation about testing, materials, and certification? This is the connection, and that's the whole point of this slide. Look at the two curves. The standard curve, the orange one, and the blue dash one. That solid line is the standard combustible material. The dashed line is the material with better reaction to fire, lower flame spread, less smoke. Same room, same ignition, but the better material pushed the whole curve to the right. It slows the growth, it delays the moment you hit the untenability threshold, and you can see it pushes the whole time of extra acid here. So this turns into this, extra time. And this is why codes and standards are very specific about which class of material goes where. Every occupancy and every location within it, the exit, the corridors, the floors, and other spaces, every single one has defined minimum class for the walls, for the ceilings, for the floors. For example, the exit must be class A. Of course, it has more strict requirement than a random room inside that building. Why? Because that's how people get out, and there's no way around it. And this is why certification is not a suggestion, not a preference, it's obligation. Because we need this. What is the reaction to fire? It's how a material behaves when exposed to fire. Its behavior when fire touch it. Will it ignite or spread flame quickly or not? How much heat and smoke does it exert? Let's take an example. Let's say I have two chairs in a single room. One chair is made of untreated wood, and the other is the same shape but made of concrete. I know it doesn't make sense, but for the example, let's say a small fire touched the chair with the wood. Within seconds, the wood ignites, flames spread across the surface, black smoke rises, the chair actively becomes fuel. Now let's look at the other chair, the concrete. Nothing happens, no ignition, no smoke, no flame spread. The chair does not contribute to fire. Take the restaurant from earlier. The fire started out from a very small socket in the kitchen, as minor fault, but instead of staying contained, it traveled all the way back to the dining room and burned the entire building. Why? As you can see, because the interior materials, the woven ceilings, the dry wood, the bamboo, the hanging lights, the furniture, they all fueled the fire. They fed it and helped it spread. That's exactly why fire reaction certification is designed to prevent. And I'm not going to discuss the issue with the building layout and the kitchen that was not isolated, but you get the idea of reaction to fire. Here. In the incipient, ignition, growth phase, all the way to flashover. Right around here where this line is, this is where reaction to fire matters. It's measured by classification, not time-based. Why? Because the materials never fail in a typical time failure sense. Their performance is qualitative and not a countdown. Let's take a curtain for example. I cannot say the curtain can stand the fire for 10 minutes. It doesn't make sense. But a door is. We'll get to that later. Before going any further, this entire slide answers two questions. How easily does the material catch fire? And how much does it feed the fire once it does? The whole letters and numbers here are just different ways of answering those two questions. It might seem too complicated, but we can simplify it. First is the combination of tests required for each type of material, from A1 all the way to F. And then classification of fire behavior, the A1, A2, B, C, D, E, and F can refer to here. A1 is non-combustible, A2 is very limited contribution to fire, B is limited combustibility to fire, better than C, C is limited contribution to fire, D, medium contribution to fire, E, high contribution to fire, and F, highly combustible, cannot be classified. And from A2 all the way to D, there are subcategories for smoke and flaming droplets. They vary from S1, S2, S3, D0, D1, and D2. Let's go back. What does this mean, the combination of tests required? And why does A1 needs both 1182 and 1716 in order to claim the non-combustible criteria? It's because one test checks how the material behaves when exposed to fire, and the other checks how much energy it holds or how much heat it can release if it burns. A material can pass one and fail the other one. That's why A1 demands both. What about A2? A2 means very limited contribution to fire. What does that mean? That means the material isn't fully non-combustible, but its contribution to fire development is so small that it behaves similar to A1. In order to claim the A2 category, we need to pass one of these tests, 1182 and 1716, but with less strict requirements or limits. And on top of that, the EN 13823, the single burning item or the SBI test. And now from category B all the way to D, limited combustible to fire, limited contribution to fire, and medium contribution to fire, use the same two tests, the 13823 and 11925. The only difference is how much they're allowed to contribute to fire growth, with B being the most strict among them. Class E drops the scenario tests entirely. Only the small 11925-2 test is done. It's just checking whether it's recognized from a small source or not. Class F means nothing, either untested or failed everything. So, as you go down the scale, the material is allowed to contribute more and more to fire. That's the whole point of the classification. It tells you how much a fire load that material is. When you read test reports, you can see stuff like B, S1, D0. That's complete engineering claim. B tells you how much it contributes to fire, S1 tells you to produce little to no smoke, and D0 tells you no burning droplets. Every character has the physical meaning of it. ECM E84 or UL 723. It is the American equivalent, but different apparatus, different fire scenario, and it's not interchangeable with the Euro class. So, the standard tunnel test is a 10-minute test that measures two things: how fast the material spread across the material, and how much smoke it produces. So there are two outcomes: the flame spread index and the smoke development index, the FSI and the SDI. And out of it comes the three classes: class A, B, C, or 1, 2, 3. It depends. Class A is the highest. Flame spread index from 0 to 25. Think of hospitals, schools, every means of egress in a building, anywhere people need time to get out safely. These spaces get the most demanding materials. So basically, Class A rating indicates that the material can limit or prevent the spread of flames, but it can still burn under high heat or prolonged exposure. Class B is the middle ground. Flame spread index from 26 to 75. Think of offices, conference centers, or mid-rise buildings. It's where regulations are still strict, but Class A materials are not mandatory. Class C is the lowest. Flame spread index from 76 to 200. Think lower risk areas, outbuildings, spaces with minimal occupancy. But regardless of the class, all three have a smoke limit of 450 SDI, because smoke kills before fire does. So, in conclusion, EN 13501 gives you the full picture, multiple tests, multiple scenarios, a detailed classification from A1 all the way to F. ASTM A84 is more direct: one test, two numbers, three classes. And this is exactly where codes and standards come in, especially local codes, which are tailored to meet the local realities. They specify which class is required for every occupancy type and every location within it. Each one has a defined minimum class for exits, for corridors, for floors, and other spaces. And also, if the building is protected by a sprinkler, the codes allow you to drop one class lower, but in certain locations. And this is all proof that that material on that wall, on that ceiling, or maybe at that floor was tested, classified, and confirmed to belong there. Because that material will either slow down the fire or feed it more. There's nothing in between. Resistance to fire answers a completely different question. It's not about whether something burns or what happens when it does. It's about how long can that element hold the fire back once the fire is fully developed. Because it matters here at the later stages. We mentioned before the reaction to fire matters here most. This matters here the most. How long will that wall or this floor or this door keep doing its job? Staying standing, keeping the fire on one side, not letting heat through. And it's measured in time, 30, 60, 90, 120 minutes, because the whole point is how long it buys you time. And that's why we say a 30-minute fire-rated door or 2 hours fire-rated wall, because it buys this time. Resistance to fire, the R, the E, and the I. What do they mean? First, resistance, or the load-bearing capacity, which means this structure keep holding its weight, no collapse. And then we have the integrity load, which is written in E, means no flames, no hot gases, passes to the other side. And finally, the insulation load means the unexposed side stays cool enough that nothing ignites from heat transfer alone. The limit is 140 Celsius average rise. But the insulation load means nothing burns. Let's say there's a bookcase around here, nothing burns from heat transfer from behind. So what we'll see in the certificate is REI. The element will be load bearing, it holds the weight, contains the fire, and insulates. For example, structural walls and floors. And then you can see some certificates with an E and an I with no R. That means these elements doesn't carry any weight. The fire-rated door does not carry the weight of the building. Its only job, or the only job for the fire-rated door, is to divide the space and stop the fire from spreading. So the structural performance is relevant in this case. But they still contain the fire and keep the other side cool. And then you can see some certificates with an E only, the integrity. That means the element is too thin to block the heat. There is no insulation. Think of a fire-rated glass door. It can stop the flame, but not the heat. Stand near it and you can still feel the heat radiating from it. The unexposed side is getting really hot, but it has some integrity. Moving ahead with the fire testing instruments. Well, personally, in order to make the results make more sense, we need to have a look at these instruments. Are these the only ones? Definitely not, but these are the most recognized in our field. And we'll get a brief idea about each one of them, starting with the cone calorimeter, and then the single burning item, and then the fire resistant furnace, the radiant panel, and then finally the Steiner tunnel. Going back to the cone calorimeter, well, most fire tests before this machine only measured one thing at a time: ignition or smoke or heat, never everything together. But when the cone calorimeter was invented, it changed all of that. And some people call it the most important tool ever created in the field of fire safety. Why is that? Because it answers the most important question in fire safety: how much energy that material releasing and how fast. Everything else in fire follows from these two questions. So basically, it's a cone-shaped heater mounted above a small sample. The exhaust hood above that collects everything that comes off when it burns. There's also sensors here. So it exposes the sample at controlled heat, and an electric spark ignites it. From that moment, everything is calculated together: how fast it ignites, how much heat it releases, how much smoke it produces, and how much mass it loses. And what comes out is the heat release rate, or the total heat release rate, fire growth rate, and smoke production. Actually, everything you need to know or understand about how dangerous a material is in a real fire. And then we have the single burning item, the SBI, EN13823. This is the backbone of the Euroclass system, or the Euroclass classification. When you see classification of B, C, and D, this is the test that produced it. This is simulated using a burning object placed in the corner of a room and transmitting a flow of heat in the neighboring walls. But some people confuse it with something called the room corner test, but they're not the same. The room corner test is a full room, 4 walls, a ceiling, a much bigger fire. This is smaller. The SBI is very smaller, controlled, and designed specifically to classify materials. And because the SPI and the cone calorimeter uses the same measuring principles, we can use the small scale cone calorimeter to predict the outcomes of the SPI. So smaller sample, low cost, quick results. If the predictions or the results are good, then we can commit to the full test of the SPI. We can save time, we can save money, and we can only run the big test when the material is ready. Everything we've covered so far are testing instruments for reaction to fire, small scale for early stages of fire. Now we move on into a different category, the fire resistance. And this is one of the most globally recognized instruments in fire testing. Anyone who works in the field of fire life safety have seen this device before. It's a large gas fire chamber big enough to hold a full-scale building assembly. Can be a complete wall, a floor, a door, a structural column carrying its actual design load. This is not a sample, this is the real thing. This instrument can be vertical for walls, doors and partitions, and can be horizontal for floors and ceilings. And some furnaces are hydraulic and can move between both orientations depending on what's being used. The furnace follows a precise time temperature curve, simulating a fully developed fire. As it burns, thermocouples sit on the other side of the assembly, the side not in touch with the fire, measuring how much heat is going through to the other side. And if the material is load-bearing, it will actually hold some weight, just like it would in a real building with fire is burning around it. Remember the R, E, and I that we mentioned before? These things are monitored together here. Resistance load, integrity load, and installation load. The clock runs until one of them fails. The time recorded at that point, that's your rating, 30, 90, 120, or maybe 180. What comes out is the exact duration of the element that was proven. 30 minutes fire rated door, 2 hours fire rated walls. That's it, exactly as it is. Moving ahead, this device is dedicated only for floors, because the floors or the floor fire travels horizontally and not vertically. So this device tests only the flooring. Carpet, vinyl, temperizing, anything you walk on is tested here. The gas-fired panel that is mounted at an angle doesn't touch the floor. It radiates heat down on it, the same way a hot ceiling radiates heat into a floor during a real fire. The specimen is ignited at the hot end. Flame travels along the surface, and at some point the heat is no longer intense enough to sustain the flame. It stops. The machine records exactly where it stops. And we extract a critical radiant flux value from this, not pass or fail, a number. The higher that number is, the harder the material is to ignite and sustain flame spread. And why does this even matter? Well, because in a fire, the floor is probably the last surface to ignite. But when it does, it cuts off, if that is a means of figures route, cuts it off entirely. So technically, I don't want a highly flammable floor in a hospital corridor or an escape route or a stairwell or a corridor that leads to an exit. I need it to be safe. And our final device is the Steiner tunnel, ASTM E84. The Steiner tunnel is different. It's the dominant instrument in the North America region, and it has been for the last 80 years. And why it was invented? Because of famous incidents like the Coconut Grove and other cases where hundreds of people died because of one common factor: interior walls and ceiling finishes. And it looks like this: a 7.6 meter enclosed horizontal tunnel. The specimen is mounted face down on the device, and then the control flame ignites it from one end to the other. And you have windows here so you can visually inspect the test. The smoke density is also measured here. And the test runs for exactly 10 minutes. Exactly 10. Any interference stops and validates the entire result. And it measures two things: the FSI and SDI, the flame spread index and the smoke development index. Remember the 0 to 25 and 0 to 150, category A, B, and C interior finishes. This is what it come out. One important limitation: The standard test measures surface bearing behavior only. It does not measure heat transmission through it. It cannot classify material as non-combustible on its own. It will just give you rating category A, B, and C. What we just covered is only the tip of the iceberg. There's a significant amount of technical data, testing criteria, and other requirements behind these topics. Use the reference numbers to explore more about them. This table is a simple idea for cross-reference. You might have the same category by different test methods. Some are similar and some very different from each other. For example, the ASTM E119 and the Europe equivalent 834, they are similar to each other. But for example, for the interior finishes, ASTM E84 is very different than the SBI 13823. They're not equivalent to each other and they're not interchangeable. So make sure you do not remove one thing above the other. I keep saying fire testing is a global language, yes, but just like any language, the same word can have a slightly different meaning from one area to another. Just like Bahrain, Saudi Arabia, Kuwait, United Arab Emirates, the same word might differ from one area to another. So check which standard your project is or the local fire requirements. Don't assume they're the same just because they cover the same product category. Double check. We've covered the basic idea and the basic foundation. Now we move on to products in practice. Starting with the sprinkler system or the sprinkler heads according to NFPA 13. NFPA 13 states clearly that everything essential to a system operation must be listed. Sprinklers, pipe, fittings, valves, whatever the standard says, no exemption unless it says. Listing is product type specific. A sprinkler head is not just any sprinkler head. An ESFR, a quick response, residential sprinkler, standard, they've all been tested and listed for the specific type of hazard based on their fuel loads. Their K factors are not the same, their RTI index is not the same, all designed specifically for their fuel loads. We cannot substitute one for the other. We cannot assume that one head fits all. That's it. As simple as that. Let's take an example of what that means. Let's say I have a low risk storage area. Everything is compliant. My sprinkler system is designed, calculated, and listed for the type of hazard. Everything is compliant. I have my safety certificate from the civil defense. Then I decided to change my business, to change the products. I will have a high risk storage area, more materials, different type of materials, different fuel loads, more combustible materials stacked together and higher than before. What changed? The hazard classification has changed entirely. But I haven't bothered to inform the civil defense or the local authority. So now my sprinkler system is not enough. It might have been before, but not for this hazard. The heads aren't the right K factor. The water density is not sufficient. Now I wait for a fire to happen so I can learn my lesson the hard way. This is because it's the most common and most overlooked compliance failure in practice. It's everywhere, in every region. So, occupancy change requires a fuller assessment of the suppression system, no matter how expensive it is, no exceptions. Anyways, the sprinkler system is only as good as the water behind it, and the water is only as good as the fire pump behind it. The fire pump is what matters here. It's the heart of the system. If it doesn't deliver the required flow and pressure to the most demanding point in the network, the entire suppression system fails. NFPA 20 states the entire fire pump package must be listed. Not just the fire pump body, everything. The pump, electric driver and its controller, the diesel driver and its controller, the atomic transfer switch or the ATS, each component individually listed, and then the complete assembled package verified together. Although the jockey pump itself is not required to be listed under NFPA 20. Why? Because the jockey pump is a pressure maintenance device that holds the system pressure during minor leaks and prevent the main pump from starting in an unnecessary way. So if the jockey pump fails, the main pump starts and takes over. But the controller for the jockey pump must be listed. And this basically should cover what the code requires from the pump, how it's built, what's listed, and what's permitted. And now, how do we verify it? From this, reading the performance curve, the pass-fail criteria per NFPA 2025. It might look too complicated. A lot of people do not understand this curve, but let's simplify it. We have the x-axis and the y-axis. Horizontal axis is how much water is flowing. 0 here and 200 here. It's percent of rated capacity. Is how much water is flowing. And we have the y-axis, or the vertical axis, is how much the pressure the pump is producing. 0 at the bottom, max at the top. That's it. So this is pressure and this is the water flow. As flow increases, pressure drops. The line going from the top left to the bottom right, that's your pump personality basically. And to understand it more, think of a garden hose. The hose is used for watering your garden or cleaning your car. When you put your thumb at the end, you'll have high pressure but low flow. But you'll have high pressure and you can increase the distance of your water. Move your thumb, you'll have high flow but low pressure. Same water, same pipe, different relationship between flow and pressure. That's the point. And we have 3 points to check. The shut-off churn, the rated capacity, and 150 overload. Shut-off is number 1, right here the chart. The pump is running but nothing is open. No sprinklers, no flow. That's the highest pressure the pump will ever produce. And it must stay controlled. Too high and you're still blowing out your entire system. As we can see here, churn must be higher than rated pressure, but must not exceed 140% of the pump rated pressure. If it does, a pressure relief valve is mandatory. That's criteria 1. Criteria 2, moving on to the middle, the rated capacity. This is the pump identity, the number on its nameplate. If you bought a pump rated at 1000 GPM and 100 PSI, this is the point where it must prove it. Now we're pushing it one more push. Far right overload. This simulates a large fire with many sprinklers open at the same time. Pressure will definitely drop. Expected, and it's acceptable. It's normal. But it must not collapse. And it must hold 65% of its rated pressure. If it can, the pump can handle real emergency demand. The 2 curves on the slide shows different pressure flow. You got one right here and one right here. This one, the pressure drops fast as flow increases. And the other one is constant or almost constant pressure. Holds pressure more steadily across the range. Both are allowed and permitted, but the flat one is generally better. But at no point should the pump produce more pressure than the system components are designed to handle. For example, if a sprinkler is designed or rated for 175 psi, but the pump reached 110 psi at shutoff, the sprinkler is being exposed to more pressure than it was designed for. Nothing may happen at that moment, but the pump is operating beyond its limit, increasing the risk of damage or failure. Anyways, beyond that, NFPA 25 ticks all over that for all inspection, testing, and maintenance requirements through the life of the system. So make sure you follow the annual and the required maintenance for it. So yeah, moving ahead to the passive systems and other products. Cladding, fire doors, and fire stops. We'll go through each one in details one by one, starting with cladding and facade systems, ACP and ACM. The fire risk of cladding. Before going to more details, we need to understand why buildings use cladding. It's actually for a few reasons and not just decorative. It's for weather protection, thermal insulation, and appearance. And of course, there are a lot of other reasons, but one of the biggest practical reasons, especially on high-rise, is weight. Cladding is lightweight, by the way. Concrete and brick add enormous load to the structure. That's why ACP panels give you the same finished look at a fraction of the weight. And that's why it became so popular, because it's lightweight, fast to install, affordable, and it looks good. but nobody was asking what it does when it burns. Starting with the famous Grenfell Tower. Everybody's speaking about it, everybody's giving lessons about it, but I don't want to talk about Grenfell anymore. Everybody's speaking about it. I will just repeat it. I will speak about the Breaker Tower in Bahrain. This was a residential tower struck by a drone in high floors during the recent Iranian aggression with the GCC countries. The impact ignited the cladding, so the drone struck the building from this side all the way to the other side. And then what happened, because the cladding was a PE core, we'll get into that later, burning droplets fell and fire ignited from below. Droplets fall, fire ignited from below, and you can see all the way down here. But what makes this really significant is another building at the same time, with the same period of time, was stuck at the exact same location, high floors, the same idea. But it had an A2 core cladding, compliant, non-combustible. The fire was extinguished within less than an hour. But this one stayed overnight. Same ignition source, completely different outcome. The cladding made all the difference. The main issue was the first tower, this tower, was licensed before Bahrain established its formal or external facade requirements. That's the real challenge with existing buildings. They were built to the standards of their time. At the end, we cannot predict where ignition come from. Maybe a fridge at the 4th floor, a drone at the high floor, a cigarette. It doesn't matter. What you can control is that material on that building when it does. That's it. So basically ACP and ACM. First is the aluminum composite panel and then aluminum composite material. What's the difference? Both look identical from the outside. Two aluminum sheets banded or bonded to a core. The aluminum face is or was never the problem. Aluminum actually melts at 660 Celsius. The core is everything. The PE core, the FR core, A2 core. The ACP is typically a polyethylene core, plastic, essentially liquid fuel wrapped in thin metal sheets. Once aluminum melts, molten PE flows and drips, spreading fire vertically in seconds. Responsible for Grenfell Tower, sentenced to death, and the torch in Dubai. It's now prohibited on high-rise building by the Bahrain, UAE, UK Building Safety Act 2022, and I think by the majority of the local fire codes, it's prohibited. The FR core is the middle ground. It's approximately 70% mineral. These panels are rated, it's actually called the fire-rated core, the FR core. These panels are treated with flame retardants and have good performance to reaction to fire. I think class B, BS1D0 or CS2D0. Remember these? C, smoke is moderate, and D is 0 droplets. There are no droplets of fire from this. And finally, we have the A2 core. It's preferred. Non-combustible, achieves A2S1D0. Does not contribute to fire spread in any meaningful way. It's quiet enough for high-rise, healthcare, schools, public assembly building. It's the best practice now for all GCC high projects. Here we have another example, the fire retardant ACM and the regular ACM, the aluminum composite material. Remember, the face sheets are aluminum both ways. The core is what burns. PE core, FR core, AT core. So the one on the right, it's restricted, no spread, because the material is fire retardant and non-combustible, and then there's no droplets falling down to avoid further spread and hazard to people. No smoke, no toxic fumes. Just like this, the droplets keep falling down. While the one on the left, let's say the PE core, the fire will keep increasing floor by floor. That's why we need something called the perimeter fire barriers, but we'll get to that later. But you get the idea of cladding to increase upwards, one floor after another. and then droplets. It will keep like that, drawing like that. This is one of the most overlooked parts of fire protection and one of the most failed on site. No matter how good your product is, something or someone will always do something wrong. To get the idea, let's say you have a 2-hour fire to the wall, you tested it, you certified it, and approved it and installed. And then at the end of the project, the electrician guy comes along and drills a hole through that and runs a cable. And then the plumber comes in and puts a pipe through that hole, and then the air conditioner guy passes a duct through it. Every and each one of these holes is now a path for fire and smoke to pass through that wall. And technically, you no longer have a 2-hour fire to the wall, now you have a wall with holes in it. That's it. No rating. And this is where fire stop comes in. A fire stop is a passive system of materials that seals an opening or a joint in a rated element. For example, that wall that has been drilled. So that element keeps its full fire resistance rating as it was before. We drilled holes, and that's usual in every project. Now we need to reseal it again in the proper way. But what people miss is fire stop is a system. A system is a specific material or combination of material tested together as one unit. What we mean by tested as one unit is we cannot merge from different manufacturers. We cannot merge stuff that is not tested together as one assembly. And barrier is simply any wall, any floor that carries an hourly fire and smoke rating. Basically, the thing we're trying to protect. Basically, we're trying to protect the protection. I hope that makes sense. And then we have the through penetration and membrane penetration. So basically, the through penetration is where something, a pipe, a cable, a conduit, a duct, passes through both sides of the rated wall. Goes in from one side, goes out from the other side. But the membrane penetration, it only breaks one side, like an outlet box of electricity. So it penetrates the surface but does not go all the way in. Now that we understand the basic idea of fire stop, let's understand how to read one. Because when you look at fire stop testing and certification, you'll see letters and numbers, just like F, T, L, W, and a number next to it. These 4 numbers build on each other. So for integrity is the F rating. It measures how long a system prevents fire from passing through. And then we have the insulation, which is written in T, measures how long a system resists heat transfer to the unexposed side. These two look familiar because just like the RAI from the fire resistance rating, the integrity and the insulation are exactly the same idea as these two. And additionally, we have optional but critical performance tests, just like the water and W and the air leakage in L. And L rating is obviously the smoke tightness, smoke leakage performance. That means that I don't want smoke passing from one compartment to the other. And double W rating means water resistance. These are the most common installation errors. And most fire stop failures on site is not because someone used a bad product, as we said before. It's because they use a good product, a certified product, and installed it wrong. So, a correct product installed correctly gives you zero protection. Doesn't matter. And first, using a product that was not tested for that situation. If there is no evidence for that exact penetrant and the exact substrate, the rating cannot simply be claimed. It may look identical to each other, it may look the same, but doesn't matter. If it was not tested for that configuration, it is not rated for that configuration. As basic as that. Second is mixing systems. Remember we said fire stop should be tested as one unit? This is why. If you take materials from different manufacturers and combine them together in the same fire stop, you avoided the whole idea of certification, because that combination was never tested together. Each piece may have its own certification, but they were never tested together as the whole assembly. The poor workmanship is basically a bad contractor. And fire installations mean the fire stop was not installed correctly and will likely fail during the fire. The gaps and voids left in the opening, the wrong product used for the application, not following the installation, the manufacturer installation instructions, and then not applying enough material for that, and the gap will be too big. Basically, it might even look good from outside, but within, it's ineffective and will likely fail during a real fire. And fourth, no label or no documentation. If you can't prove it, it didn't happen. No matter how perfect the installation is, you will fail the inspection. And finally, we have the wrong side, wrong substrate. Many systems are tested for installation on one specific side of the wall, or maybe on one specific material. Install it on the untested side, or change the material itself, like from cement to plasterboard, and the performance will drop. It's no longer compliant. So, the discipline is simple. Install it exactly as per the listed system with an experienced contractor, licensed and registered by the local authority. Follow the rules. The first image is an application overview or a cutaway of a building, showing every place a fire stop should live in. Door penetration, mechanical track system, gypsum, alternate enclosures, joints, beam insulation, curtain wall gap, and glazing. So basically, every one of these orange circle details is a hole that has to be sealed with a tested system, or an opportunity for fire and smoke to pass through that. The middle picture is a through penetration. You can see the fire stop collar right around here on the combustible pipe. That collar contains a material that expands when heated and crushes the pipe as it melts, and it will seal that hole. Think of it like clenching fists. Whenever things go wrong, it will clench on that combustible pipe. And then you can see the insulated pipe and the cable tray with the fire sealant. That's the most common fire stop on any project. Whenever you go to any project, you should see that. And the third one is the perimeter fire barrier. This one is mostly forgotten, to be honest. This is the slab edge where floor meets the glass curtain wall. There's always a gap there, by design, always. And fire loves that gap because it lets fire or flames spread from one floor to another, up and also to the outside of the building. And you can see the mineral wool staffing packed inside that gap and the fire stop coating over it. This is what stops fire on the third floor from becoming a fire on the third floor, the fifth, and the sixth. And the one thing to carry away from all of the slides regarding fire stop is that the panel, the penetrant, the gap, and the seal should always be tested together as one unit or one system. Change any of that, change any of the installation requirements, bigger gap, wider gap, a different sealing, anything you change, and the rating no longer applies. You're back to the untrusted hole that was made by the electrician or the HVAC contractor. Follow the required standard for the joints, penetrations, and the perimeters. Moving ahead to the fire-rated doors. You may be wondering, why is a UL certification mark on a slide about fire doors? Because it's the foundation of everything. Every fire door must be listed and labeled by a recognized third-party certification body. This is what NFPA 80 said, by a third-party certification body. So, now, UL is the most common certification body you will see in our field. So I put it here because you'll encounter. And why UL? Because it's the most common certification body that we have in our field. And UL has 3 different types of marks you need to know. First is the UL listed, and then UL classified, and then UL recognized. First, UL listed. This is the most important mark. UL listed means the entire product was tested and meet UL safety requirements as a whole product. So think of it this way. The complete fire door assembly will be UL listed. It will be ready to install, tested together as one complete system. I'll just take the door, install it directly. That's UL listed. To simplify it more for the non-experienced people, let's say an iPhone, the whole phone, the screen, the battery, the charging port, the motherboard, all tested together as one complete product ready to use out of the box. The iPhone, that is UL listed. The control panel, that is UL listed. The complete door assembly, that's UL listed. And now we have the UL classified. UL classified means it is tested for special conditions or special uses only. Unlike UL listed, which covers all aspects of safety, UL classified just addresses certain features, such as fire resistance or something else, just something specific. And it cannot apply that anywhere else, just for a specific purpose. And related to door, that means the door was evaluated specifically for fire resistance properties and nothing else. And just like the iPhone example, let's say the iPhone is tested specifically for water resistance only. Not everything, just that one property. If it passed the water resistance, it will get the UL classified mark. And finally, UL recognized. This mark applies to components intended to be integrated into a final product. These components cannot be used on their own, but must function as part of a broader system. Let's say the door closer will be UL recognized and it will be part of the whole assembly, like a hinge, an intumescent seal, just like individual parts that go into the door assembly. They cannot do the job alone, so they recognize part of a whole assembly or bigger assembly. Going back to the iPhone, the battery of the iPhone is UL recognized, just like the battery of the control panel. It cannot make a phone call on its own. It has no function by itself. It cannot detect fire on itself. So it is tested and certified to work safely inside a larger product. So in general, UL listed, the whole assembly system passed, ready to install. UL classified is tested for one specific thing only, and UL recognized just a part of something bigger or a bigger listed system. That's it. And just what like we said, NFPA 80 or NFPA does not require UL specifically. It requires a third-party certification body. UL is just most of the common you will see. Beyond all certifications, any different type of certification from any certification body, NFPA 80 states that at minimum, the label for fire-rated door should contain 7 information. Number 1, the words fire-rated door or fire door. Number 2, the manufacturer name or a code that can be traced back to the manufacturer. Number 3, the marking of a third-party certification agency, UL, Thomas Bell, Salman, anyone. The marking of the third-party certification should be mentioned at the label. Number 4, the fire rating, how long the whole assembly holds, 20, 30, 45 per hour. The duration the assembly must hold should be stated at the label. Number 5, a unique serial number, if provided by the listing agency. And then number 6, the fire test standard and the duration to which the assembly was tested for example, UL10C, UL10B, or whatever the standard was, it should be mentioned to according to which standard the door was tested for it. And number 7, temperature rise rating. It's how hot the protected side gets after 30 minutes, as we can see right here. And this basically is critical for stairwells, because a door that can stop flames but conducts extreme heat through that escape route hasn't protected anyone. It just made that exit stairwell an oven and it turned it into a heat trap. And then glazing ratings. Any glass panel over 100 square inches must carry its own rating. Why? Because let's see if this glass is 45 minutes and the door is 90 minutes. That means the entire door will be 45 minutes and not 90 minutes. The weakest element sets the rating. The weakest element from all of these or any of these will be the rating of the door. And a door is not just a door. The doors and assembly. Every single component you see here, the closer, the hinges, the latch, the glazing, the seals, the panic bar, they make what a fire door is. And all of them must be tested together as one complete unit. I cannot merge them from different manufacturers, from different products and materials. They should be all tested together as one unit. And in the next slide, we're going to see a video about UL10C fire resistance testing, about a fire-rated cold room hinge door. What we just saw was the UL10C fire resistance test. And in order to pass the UL10C, the door assembly must do three things. Number one, resist fire for its rated time, 1 hour, 130 minutes, depends on its rated time period. Number two, do it under positive pressure conditions, because this stimulates real life conditions. Number three, survive the whole stream test after the fire exposure. So when you see a UL10C on a fire-rated door label, it means that that door was tested under the most realistic fire conditions and passed. So basically, UL10C is the golden standard for making sure the fire door will actually perform the way it's supposed to do when a real fire happens. The structure, firefighting, protective, and symbol are basically the turnout gear. But I would stop for a second. To all firefighters and first responders, we, from the fire prevention side, want to say thank you. You're the reason that we do what we do. When we work on the prevention side, every door we inspect, every fire stop we verify, every active and passive requirement that we require on the building, it's all connected to you. Because when prevention fails, you're the one who answers the call. So before we talk about gears and standards, thank you for your courage and thank you for your sacrifice. And we need to understand that this is not just a clothing standard. This is a science behind what stands between a firefighter and a fire. Every layer, every material, every performance requirements exists for one reason: to bring them back home to their families. And there are two standards, NFPA 1970 and EN 469. So So basically, NFPA in 1970 is the American standard that covered the requirement for certification, design, performance, and testing for the protective clothing equipment. The American approach is very simple. One high pass or fail bar. Either the gear meets it or not. No levels, no tier, that's it, pass or fail. While the European standard or gear is tailored to more defensive strategies as seen in Europe, where operations often require lighter, more breathable options suited to various levels of exposure. Are they both the same or equal? Definitely not. There are a few main differences. First, the thermal protection. NFPA uses one combined number called the Thermal Protective Performance, and it must be 35 or higher. That single number covers both flame and radiant heat together. Simple, it meets it or does not, nothing in between. While the EN separates them. Flame is tested by itself and radiant heat is tested by itself. Then it grades it level 1 or level 2. Level 2 is obviously the higher protection for interior operations. And then the heat stress and breathability. NFPA requires a heat loss of 205 watts per square meter or higher. This measures how well the gear lets body heat escape. The higher the number, the more breathable the gear is, and the lower the risk of heat stress. While EN has a different approach. It measures water vapor resistance and it's called RET or RET. The lower the RET value, the more breathable the gear is. Z2 is better rating, meaning lower resistance and less heat stress on the firefighters. And now for the water penetration. NFPA builds water resistance directly into the linear and seam barrier requirements. It is part of the construction barrier. While EN uses hydrostatic resistance rated as Y1 and Y2, Y2 obviously means higher waterproofing. And regarding the labels, NFPA uses a certified and symbol label with a strictly defined reflective trim layout, while EN has a pictogram showing XF, XR, Y, and Z rating, each graded 1 or 2. If all rating shows a 2, that is a level 2 gear. So why do we choose one over the other, and why is that? Well, NFPA is built for aggressive interior attack, higher thermal thresholds. Basically firefighting tactics going deep into the structure. While EN gives you flexibility. You match the level to the mission. It also allows a two-piece design and prioritize breathability for longer duration operations. So bottom line, NFPA sets one high bar and you either meet it or you do not. That's it. EN lets you choose your level based on your risk. But both standards test the full 3-layer ensemble, never the outer shell alone. Both protects firefighters. The difference is the philosophy behind how they do it. So it's on your preference or the local civil defense preference. There's nothing better than the other. This slide is all about Bahrain Fire and Life Safety Code. And the point here is simple. Every product installed in a building in Bahrain must be tested and certified to a recognized standard. The code tells you exactly which standard applies to each product. And how do we find that? At the end of every relevant chapter, the applicable test standards for that systems are listed right there. For example, I'm looking for the standards for fire pumps. It will be at the end of section D, chapter 2, related to fire pumps. And smoke control and smoke management at the end of this chapter, fire extinguishers at the end of the chapter. And in general, not just Bahrain Fire and Life Safety Code or UAE Fire and Life Safety Code of Practice, or the Kuwaiti Code or the SBC, Saudi Building Code. All local codes do not just tell you what to install. They will tell you what every product must prove before it gets installed. So know the chapter, find the standard, verify the product, and then install it. Do not try to skip any part of the procedure. There is no shortcuts. Alright, we are now almost past the second half of our presentation. The anatomy of fire testing reports. A fire test report is not a marketing document. It's not a data sheet. It's not a catalog. It's a legal instrument. Proof that that specific product in a specific configuration was tested under accredited conditions and generated results. And it must contain 7 mandatory fields. First, the laboratory identity, test standard and edition, specimen description, test date, test result, manufacturer and sponsor, and report number and validity. Starting with laboratory identity. I need to know the name, the address, the accreditation number, and scope of the laboratory. And the scope must list specifically the test method and edition. For example, a lab accredited for EN1363-1 cannot automatically do EN1363-2. The scope covers the exact same testing standard and year. And second, test standard and edition. Not ASTM E119, no, it's ASTM E119-2022 or 2025 or the latest edition by the time you watch the video. The year matters, and always check the edition of the year. And then the specimen description. Every material, every dimension, every fixing details, if anything on site differs from the description, the report does not cover it. And then the test date. The date the test was physically conducted, not the report issue date. The date the test was conducted. Both must be stated. They are both different, but both must be there. And then the test results. Not just pass or fail, the numbers itself. The temperatures, the FSI, the SDI, the heat release rate, the exact numbers. And then the manufacturer and sponsor. They can be 2 different parties. Both must be stated and verified. And finally, report number and validity. Every report has a unique number. That number is how we trace it back to the lab, to the test, and to the product. So if someone cannot give us that number, I think we do have a problem. Now, reports do not have an expiration date, but the standards they reference do get updated, and new editions come out every few years, or whenever it's needed to be updated. So it's the laboratory responsibility to keep up. Where a standard gets revised or amended, they are expected to test to the latest edition or to the latest version from that point forward. So if a lab runs a test from an older version after a new one that's already published and in effect, the authority having jurisdiction or the HG may look at the report and may refuse it and might definitely will not accept it. So it does not matter if the product passed or not. It matters if it was tested to the right edition at the right time. Always check edition year. Always verify it was current when the test was conducted. So 7 fields, every one of them matters, because accepting a fire test report is not an inspection checklist. It's verifying what is in that building was actually tested, actually passed, and actually matches what is installed. It's a big responsibility. Look, I'm not going to make you an expert at running test reports today, but I'm going to give you the fundamentals, the things you need to know when our reports land on your desk. This is about the Euroclass EN 13501-1 report, the reaction to fire. As we explained earlier at the beginning of our presentation, EN 13501-1 divides building materials to 7 main classes based on fire behavior: A1, A2, B, C, D, E, and F. So in addition to main classes, materials are also classified as S1, S2, S3, and the droplets D0, D1, D2. We're not going to repeat that. So remember that every Euroclass rating requires a specific combination of tests, as we mentioned. That's them, simplified. Each one of this should be listed in the test report. As basic as that. A certificate claiming A2, S1, D0 based only on EN 13823, it's complete. Something is missing. And if only EN 13823 is provided, the A2 claim is unsupported. Something is completely wrong, and the document is not compliant with the classification requirement. So regarding the test on the right side, well, it's not a legit test, by the way. The test report you see on the right is not a real testing document. I have taken relevant sections from different pages of actual reports and combined them all together for demonstration purposes to show you what each field looks like and where to find it. It must list the laboratory or the name of the laboratory, name of sponsor, the report reference number, and the test method with the date. Verify every test method listed and it should match the required combination of the claimed class. Then the classification. It states their class result. Then check the fire behavior, smoke production, and flame droplets table at the bottom. All three must be present. And read the final statement. The classification is only valid for the conditions of use described in the report. That means the exact product and the exact configuration tested, nothing more, nothing less. And it should be at the end. So, in summary, check the class, check the test combination behind it. If the test does not match what the EN13501-1 table, because -2 is resistance to fire, requires for that class, the reaction test or the reaction to fire test does not stand correct. Now we move on to ASTM A84, the Steiner tunnel test. Again, the test report is just for educational purposes and this is not a real test report. So, what to verify? The specimen thickness and density. The specimen thickness and density must match the product submitted. The number in the reports must match exactly the product being submitted. A test on a 4mm panel does not apply to a 3mm panel. If the numbers does not match, the report does not apply. So the specimen thickness and density must match the product submitted. That's number one. And then the specimen orientation. We've mentioned before that the Steiner tunnel mounts the specimen face down on the ceiling. So if there's anything wrong or the orientation is different, then we need to verify what is wrong. And then both the flame spread index and the smoke development index must be stated with numerical values, the actual numbers. So if you're comparing your products, you're verifying the margin of compliance, you need those numbers. Class A tells you it's passed, the number tells you by how much. So you need the numbers. As you can see here, flame spread index, FSI is 15, and SDI, smoke development index, is 70. So you need to see the correct numbers or the actual numbers of the data. And then 10 minutes test duration was complete without premature termination. The full test is 10 minutes, mandatory. Any earlier termination invalidates the whole result. The report must confirm to the full duration until completion. And then the witness engineer signature and accreditation mark, both must be present. No signature, not a valid report. And then the edition year. For example, if 2025 is the newest edition, then the test must be done to the current edition. And then if SI or SDI is reported as 0, this is physically impossible. Any organic material, wood composite, rubber, textile, will always produce a measurable flame spread in the Steiner tunnel test. A result 0 that's physically or scientifically impossible. So we covered reaction to fire, AN13501-1 and ASTM A84. You know the basic idea on what to look for, what to verify, and what to reject. Resistance to fire, that's on you. This is your homework today. You can find test reports anywhere on the internet. Some might be older versions, but that's alright. Read it, understand what the rating means and how the assembly was tested, and understand the test report. Because in our field, your post will land on your desk and no one will sit with you, no one will teach you, and no one will walk you through it. They simply expect you to know it. So learn how to find information when no one will provide it for you. Learn how to open a document and find the answer yourself. And this one trips up even experienced engineers. A listing is not general approval of a product. It is a permission with boundaries, and those boundaries are the listing conditions. Let's take an example to understand that furthermore. Two smoke detectors, manufacturer A, manufacturer B. both listed to UL 268. Same standard, both compliant products. But manufacturer A covers a maximum radius of 6 meters and works for ceiling height 3 to 9 meters only. Manufacturer B covers 7 meter radius and works for ceiling heights from 3 to 12 meters. Same standard, but different boundaries. So if you take manufacturer A product and install it in a space with 10 meter ceiling, that listing is violated. The product is now unlisted for that application. And here's the part most people miss. Even if the spacing looks fine on drawing or layout, even if NFPA 72 is satisfied, the listing condition overrides it. The listing is the binding constraint for that specific product. So again, basically two products, same standard, different limits. The layout must match the specific product specified, not just the brand, not just the series, the exact model, the exact listing conditions. This is not every reason to flag a report, but the possibility that you will encounter one of them is very high. First, the laboratory is not accredited, or if the accreditation scope does not cover the specific test method cited in the report. Second, wrong edition of the standard. Let's say ASTM E119-16 done recently at a time when the current accepted edition is the 2026 edition. That's a big no. Different editions carry different acceptance criteria. Always verify the edition is current and accepted by the authority having jurisdiction. You cannot accept older versions instead of new ones. And then discontinued at sponsor request. That's suspicious. The test was stopped before the specimen failed. So let's say I ran a test for 55 minutes and stopped it before my product failed. I cannot claim the product is 60 minutes fire rated. The demonstrated rating is 55 minutes. That's it. Not 60, not 50, exactly 55 minutes. Always double check and verify when you see discontinued at sponsor request. There's always something wrong you can find there. And then specimen does not match the product. Different core material, different thickness, different surface coating, different hardware. If the specimen description does not precisely match what is being submitted, the report does not cover it. No host stream tests for rated assembly. For doors, wall assemblies, and anything under NFPA 252 and ASTM E119 or UL10C, a host stream test is mandatory after the endurance test. So a report without them when it was required means the test was not complete or something is wrong. There's always an exception, but the exception should always come from the entity that's issuing the standard and not from the lab itself. They cannot exclude, they cannot change anything about the test standard. FSI of 0 on a combustible material or a 4-hour furnace test with no thermocouple reading above the ambient temperature. Think about that for a second. Any material that contains carbon will produce measurable results in a fire test. Always. This is physics. And when you see numbers like that, those results were not achieved. They were written and fabricated. So you can request the raw data or simply reject it. And now we're at the final part of our presentation. So everything in fire safety compliance sits inside hierarchy. Who makes the rules and who follows them. So it's basically like a pyramid. But on this slide we're going to see it left to right instead of top to bottom. Starting from ISO, the International Organization for Standardization. And many organizations are already familiar with the concept of management systems. In fact, I think many already have the QMS or the quality management system based on 9001 from ISO. So technically ISO does not run any lab or certify any products. What it really does is develops and publish uniform international standards for technology, manufacturing, and business management. In our field, that's basically writing the rules that define what capable laboratory is or what a good certification body looks like. And the two standards that matters for us are these two, ISO IEC 1725 and 65. So basically ISO/IEC. That means that the standard was jointly developed and published by both organizations, the ISO and the IEC, the International Electrotechnical Commission. And going back to the 17025, it's the international standard for testing and calibration laboratories. It basically means that these standards enable labs to demonstrate that they can operate effectively and generate valid, globally accepted results. So any lab that does any kind of testing must have the ISO IEC 17025. And then we have the ISO IEC 17065. It's the international standard that set the requirements for organizations that certify products, process, and services. And now Global Accreditation Corporation Incorporated. Well, before 2026, the international accreditation system was split into two, the ILAC and the IAF. I think these two are familiar. So the ILAC, or the International Laboratory Accreditation Corporation, handled laboratory accreditation, test reports, fire tests, and calibration, while the IAF, or the International Accreditation Forum, handled the accreditation of companies that issue certification for management system, products, services, and personnel. So they were basically two separate organizations and two separate agreements. But on the 1st of January 2026, they formally merged into one single body. So instead, if I have to deal with two separate entities, I'm dealing with one uniform global ACI, or global accreditation. And now there's a transition period from 2026 all the way to 2029. And during this time, we can see both the old marks and the new marks on paper. But after 2029, there should be only the new mark. And now we have the national accreditation bodies. Think of these as the local version of this. Their job is to go out and verify that the labs and certification bodies within their jurisdiction actually meets the standards issued by ISO. And then the national accreditation bodies make the global accreditation, sets the global rules, and then the national accreditation bodies make sure everyone in the regions follow them. And for the Middle East, the body we need to know is the GCC Accreditation Center, or JAC. So, GCC Accreditation Center makes sure or ensures that certification, inspection, and testing bodies operating in the region meet the international or the highest international standards. But before JAC is able to do that, GCC or JAC must be audited at first. So the GCC must be accredited by the global accreditation, and then JAC assess the laboratories and the certification bodies against the standards. And now the laboratories that physically conduct the fire test and issue the test reports. The accreditation is ISO IEC 17025. So when we say an accredited lab or an approved lab, that means the lab has this accreditation, 17025. But the accreditation is not general and not for everything. It has specific authorization by test method, by edition, by product category. So it's not one certificate to test everything you can do. And they do get a calibration check, for example. Let's say I have a sample, I send it out to 10 different laboratories. They all run the same tests. and then all the results get compared together. And if 9 labs came back with similar numbers and one with different or slightly different numbers, I think that's a problem. The accreditation needs to be reviewed again, because all of them needs to give me the same exact results. And this is just an example, because these test reports carry legal weight, because they are verified on a continuous surveillance cycle and not once at initial accreditation. So let's say I have a product. If it failed at emerged safety laboratories, it will fail at GCC Technical Services, it will fail at Advanced Construction Technologies, and it will fail in Thermosbil. So a product fails the test at one accredited laboratory, it should fail the same test at another accredited laboratory. There is no way around it. You cannot solve a failed test by moving to a different laboratory. If the test standard and the product are the same, they will all give you the same outcome and the same results. And now, the certification body. These go further than just testing. They audit factories, issue marks, publish live directories, and conduct ongoing surveillance, including unannounced inspections. The certification bodies are themselves accredited by the national accreditation bodies under ISO IEC 17065, carrying their own peer-reviewed accreditation behind every certification mark they issue. Can any organization test and certify at the same time? Yes. An organization can hold both ISO IEC 17065 and the 17025. For example, we have Thermosbil, right? Runs the test under ISO 17025, and then they issue the certification mark under the 65. But, and this is important, they must keep the two functions completely separated from each other. The testing side cannot influence the certification side. And at the end of all this, the AJ review. At this point of the application sits the local authority. It verifies the chain, checks the certification mark, definitely within the correct framework, and then verify listing from public directories, which is issued here, and then confirms that certification configuration matches what is being installed on the site, and issues or withhold approval. Now we understand how things work. A product just doesn't arrive at your office with a mark on it and get accepted. Behind that mark is a laboratory that was verified. And behind that laboratory is a national accreditation body that authorized it. Behind that accreditation body is a global agreement that recognizes it. And behind all of that is ISO writing the rules that everyone is following. Every layer verified by the layer above it. And this is why a UL listing from the United States gets accepted here in Bahrain, and this is why an LPCP certification from England carries authority in UAE, and this is why a fire test conducted in Dublin applies to a building in Singapore. This is one global system built on trust, built on verification, built on mutual recognition. That's the whole idea. Unification. And here we have an example. The ISO IEC 17025 accreditation for the Emirates Safety Laboratories. As you can see, this is not a general approval for everything the laboratory does. And I'm not going to go further into the procedures of ISO 17025 and how to get accredited. That's a completely different topic. You can investigate the process further on your own. What the document covers is specific. To only authorize the laboratory for the exact test listing in the accreditation scope. As you can see, we can first see the accreditation. And then to whom? Then based on what? Based on ISO IEC Standard 17025 2027 edition, general requirement for the competence of testing and calibration laboratories. And then we can see the scope of the laboratory. As we mentioned before, a lab accredited to perform one fire test standard is not automatically accredited for every other fire testing standard. As you can see, the fire integrity of electric cables BS8434-2 does not mean they can do the -1, only -2. And then you can see right here, -1 and -2. It needs to be clear. So when you see a test report, you can refer back to this and ask 3 questions. Is the test method listed in the laboratory accreditation scope or not? And then, is the edition here of the standard covered by the scope? And then, is the product category covered by the scope? If any of these three does not match, then the laboratory may not be accredited for that specific test. Moving ahead, let's say I got my product tested and certified. Is that the end of the line? Definitely not. Product certification not something you do once and then you put it in your company portfolio or on your catalog. No, it's an ongoing relationship between the manufacturer and the certification body, enforced through a structured surveillance program. You can see the simplified cycle because it goes on deeper than this. So, first step is product documentation and sampling. This is the phase before the testing. So the manufacturer submits the products for evaluation. Then the certification body reviews everything from materials, from dimensions, from component to construction, everything. This is the starting line. Before any testing happens, the product must be documented in full detail. After the product is fully documented, testing must happen per the applicable standard. The product goes to an accredited laboratory. Fire test is conducted against the required standard. The specimen pass, obviously. Then the results are recorded, and this is the technical evidence behind the certification. After that, the quality management system or factory quality system audit. What does that mean and how is that relevant? The certification body audits the manufacturing facility. And this exists to verify that the factory operates under a quality management system. And this should answer one question. Can this factory keep producing what was tested the exact same way multiple times? And after everything is approved, the certification and the mark authorization. If everything passes, the certification mark is issued. The listing is published in the public directory, we'll get to that later, and the manufacturer is authorized to apply the mark to the product. But this is not the end. This is the beginning of the surveillance cycle. Because once the product gets certified, the product does not get left alone. Surveillance visits happen, sometimes announced, sometimes unannounced. And production samples are usually pulled from the market and not from the manufacturer's own stock. I can make a perfect sample of my stock for any visit, but whatever's in the market, that's the real thing. So they pull samples from the market, from distributors or retailers, and they retest them again, just to confirm that everything is working as it is. And periodically, typically every 3 to 5 years, the products must be recertified against the current edition of the standard. And let's say a few years after my certification, everything worked perfectly fine. All my surveillance and audits are passing greatly. But let's say I'm out of a certain wood I'm using for my fire doors. If a manufacturer wants to change anything about the certified product, different raw material, different supplier, different dimensions, they must notify the certification body before making any single change. No matter how minor it is. For example, let's stick to it. Wood from different source, different humidity conditions, different growth criteria can produce different fire performance results. That change must be evaluated again. If they change without notification, that's immediate suspensions. I've mentioned suspension. Yes, that means the certification body can suspend or withdraw the certification mark entirely based on these factors. First, failed surveillance inspection. A product pulled from the market does not match what was approved. Something was changed along the way. Refuse access to factory. The manufacturer blocks or delays the certification body team from entering. Unreported design changes. The product was modified after certification without following the change management process. The standard edition not met. Every few years, standards will be reviewed, updated, or changed. So a new edition of the reference standard introduces conditions the products no longer meet. And because the manufacturer has a defined transition period to recertify, and if that period passes without action, that's suspension. And then the counterfeit mark, using a fake additional marks on the product, something you're not certified to use. And then failure on the surveillance sample test. Let's say a production sample pulled during a routine inspection fails the product standard tests. And this is what I tell people. Verify the listing status on the day you review the document, not the day it was issued, the day you review the document. Because a certificate printed last month showing status active may be suspended today. The paper does not get updated, but the database does. Always double check. UL Product IQ. It's the official online search engine and database by UL Solutions. By the way, it's free access and can be used without logging in for quick and swift search. And as I previously mentioned, paper certificates can be falsified or altered or changed or fabricated. But the online directory is a free public platform where anyone can confirm that a product is UL listed and the mark is still valid. And you can search by almost any criteria, by file number, product type, design number, model number, or even the company name. Just randomly entering any company name in your mind, you can find the directory and the list of products they have, which is certified, of course. So, what do I need to find a product? Basically anything. First, with the CNN, the category control number is the product category code. It tells you what type of product the listing covers. And where do I find it? It will be right there on the product label. And if you ever came across a product type you do not recognize, go to Product IQ, type the product name as a keyword, and the CNN will come up. And if you don't have it, it's no problem at all. You don't need a CNN number. Search by company name or model name. Easy and simple. And then we have the file number, one letter followed by 5 digits like E12345 or X12367, anything, just a letter and 5 numbers. Every product under one manufacturer's listing shares a file number. Search by the file number and you can see every model that manufacturer has listed under that standard. And where do I find it? On the product label, on the paper certificate. It's always there, always. So take that number, go to Product IQ, enter it, and it will show you the company name and every model covered under that file, the listing status, and all the certification details you need. And then the listing status. The most common status are active listing and recognized component. Suspended means a compliance issue is under investigation, and withdrawn means permanently revoked. Neither of these is accepted. So always check this status on the day you are making the approval decision. And then the product name and model, that's common sense. The listing covers specific models by exact designation. A listing for one model does not automatically cover another model even from the same manufacturer. And then the listing conditions. These are the installation and use restrictions. They carry the same legal force as the standard itself. So a sprinkler listed for light hazard cannot be used for ordinary hazard or extra high hazard. As simple as that. So as you can see, the procedure is very straightforward. Go to Product UL IQ, enter the file number or model number. Confirm status is active, confirm the model matches exactly, confirm the listing condition match what is being installed. That's it. And everything we mentioned, you can see it on the right side. The product category, the file number, the model number, and the company itself. And in the next slide, I will show you exactly how to do this live. As you can see, it's not too complicated, easy to use, and doesn't take much time to verify. Now, is your product use the only directory you will ever need? No. UL is the most common certification body. Yes, we all know that. But there are others. Thomas Bell has its own certification directory on TBW Cert. The PCB has the Red Book, FM approvals have guides. Every certification body maintains a live public directory. The principle is the same across all of them. Find the product, verify the status, confirm the model and listing conditions, and match what is being installed on the site on the paper in front of you. 60 seconds, that's all it takes. And in the next slide, I'm going to use the Thomas Bell Wright, the product certification portal, tbwcert.com. NFPA Global Solutions. And my guess is most people have not yet heard about it. And it was launched almost 2 years ago in 2024. NFPA has existed since 1896, a century of writing codes and standards. And for all of that time, NFPA role was clear. Write the standard, publish it, and train people on it. But NFPA itself never went out and tested the products, never certified anything, and that was always someone else's job, the testing and certification bodies. Now, here's what changed. NFPA own stakeholders, engineers, installers, AJ, governments started asking for more. They wanted compliance tools, they wanted advisory support, they wanted NFPA to help them implement the standards and not just publish them. But as we all know, NFPA is a non-profit organization. They cannot do a commercial testing, product certification, and fee-based services. So what did they do? They created a for-profit organization, a separate company, a separate board, but owned entirely by NFPA. And the strategy they're running is almost identical to what the underwriters' laboratories did decades ago. Acquired establishing labs, expanding the scope, and building a recognized market. They started testing fire and life safety products like sprinklers, fumes, dry chemicals, and also in the electrical field, industrial control panels, battery energy storage systems, and building products. And they also have a field evaluation services, which lets you, if you get a piece of equipment on site that isn't listed, maybe custom built or modified, one unique product, the field evaluation is the only pathway, which basically means an accredited body comes to the site, evaluates the installation, and issues a label. NFPA Global Solutions offers that. And some people are wondering, how can the same entity that writes the standards test against them? Short answer, UL or underwriters laboratories have done that for more than 100 years. Because it's technically two different organizations. For example, UL Standards and Engagement develops the standards, and UL Solution tests against them. And just like NFPA, NFPA writes the standards, and NFPA Global Solutions will test against them. So this concern is invalid. No single organization can write a standard and slip something self-serving in. It's just not possible. Because the standard has to pass a committee of competitors, regulators, and academics who would immediately flag it. The same thing applies to NFPA 300 plus standards. And whether you see this as an advantage or a concern is a fair debate, but it changed the relationship between a standard certification in a way we haven't seen before. And they have their own certification mark, and when you see a mark you don't recognize, you just have to double check and verify, as we keep saying. You need to know what it is and how to check and look for it. And they also have their own directory listing in their website, nfpaglobalsolutions.com. And by the end, the market is moving and the world is changing, and we need to keep our information updated. I've met several people recently that have no idea that this came in 2 years ago. It's a very long time to not keep track of it. We've talked about directories and database. Now let's talk about what you can actually do when you're standing in front of a product on site. First thing you should do is finding the label. There's always a label. There's always an identification number. It's impossible to have a product without an identification number, just like our ID. So that means every product will have a serial number. And you can also identify the manufacturer company on the product. Now, let's look at the fire extinguisher on the left to see what I mean. You can see they are listed, model number and file number. And you can also find different markings on extinguisher, for example, a PCB or PSI Kreis mark. And different products carry their marks in a very different way. On extinguishers, they're going to be printed directly on the label, easy to see. Fire pump is going to have a metal nameplate bolted to the unit. Model, serial number, rating, and certification mark all in one place along with the manufacturer identification. And on fire door, for example, is going to be when you open the door, you can find the mark in between the hinges. On fire sale products, on the packaging, and sometimes on the product itself. Some are obvious, some you have to search for. But keep this in your mind. These marks can be faked. This way, finding the mark is only the first step, not the final answer. Because I can fake a label, I can fake a mark, I can do anything on a product I have on site. No one's going to see. And there's always going to be something wrong. A difference between a genuine and tested and labeled and certified product is never the same as a fake product on site. Now, going back to the fire extinguishers, something I encountered in my field, and you will definitely do. You walk up to a fire extinguisher, you look at the label, and all you can see is tested according to ISO 7165 or manufactured according to ISO 9001. No UL mark, no PCB, no third-party certification at all. Basically, ISO 7165 is the performance standard for portable fire extinguisher. It defines what the extinguisher must achieve, the safety requirement, the performance requirements, and the construction requirements. But ISO 7165 itself is not a certification. It is a standard, just like any other standards. And anyone can print ISO 7165 on a label. No independent body went and verified that this specific extinguisher actually met it. That's the first one. The second one, ISO 9001. This is the quality management system standard. It certifies the factory process, not the product. It means that manufacturer follows consistent documented procedures in how they design and produce their products. So technically, ISO 9001 on a fire extinguisher is nothing. It's not relevant. And you may ask, why do manufacturers put it on the extinguisher label? Because it's added credibility to the eyes of someone who does not know the difference. So most people assume the product was tested and certified. Those people do not know the difference. So do not be among these people. And is ISO 9001 relevant in our field? Yes, but not in the same way people might think. And we've mentioned it before. When a certification body audits a manufacturer, one of the things they will check is having a quality management system. And the ISO 9001 is the minimum requirements. It alone is not a compliance evidence. Know the difference and stand by it. Always double check, always verify, always have doubt. Because that doubt may save lives. And now we are at the final part of our presentation, the summaries and takeaways. So in conclusion, what's the difference between a test report and a certification? First of all, a test report is a one-time evaluation. One specimen, one day, one set of controlled lab conditions. The results apply to that specimen on that day only. The factory could change its material in the next test, substitute it with a cheaper one, reduce its quality controls, and there's no surveillance, no audits, no public directory, and you cannot verify it online. So it's a one-time claim. So technically, a test report is only acceptable for research and development R&Ds or for early stage design verification. And there's very explicit scenarios that the authority having jurisdictions might accept a test report only. What is not enough on its own for any life safety products does not prove anything. While third-party certification goes much further than that, it means an accredited organization has reviewed the manufacturing process and determined that the product complies with the specific standards, which includes formulations and materials, reviews, testing, and facility inspection. All of that is certification. And it takes more of a holistic approach, integrating not just the test data, but regular audits of the manufacturing company, the process, the quality control, and compliance checks to ensure that the product continues to meet the safety standard as it was tested. So technically, the test report is only a one-time evaluation. On this day, the product has passed. But after 2 weeks, I cannot guarantee that the same product, if it's the same product, manufactured to exactly the same process, will pass or not. And certification basically means that this product that was tested today and passed, I can do 1,000 more of these and can still pass. And if something goes wrong, the product is suspended immediately from the certification directory, and the manufacturer cannot hide it. So that's basically the main difference between them. And codes and standards will always require a third-party certification. They always refer to be listed. Listed means third-party certification. For key takeaways, starting with a test report is not a certification. A test report is one specimen on one day. The factory could change everything the next morning and nobody would know. Third-party certification with factory audits, surveillance, and announced inspections is what proves that the product in your building today is still what was tested, or the same what was tested. Not confuse these two. Second, always verify online, every single time. No exceptions. No matter how swift the application is, do not approve without checking online. The papers can be faked, the database cannot. The UL, FM, or PCB, Thomas will write, all live, all real time, and it takes only 60 seconds or even less to check. And check it on the day you make the decision, not when the submittal came in. And third, the assembly configuration is what is certified. What it means by that is not the name, not the brand, the exact configuration that went into that furnace. Every material, every dimension, every component, every fixing details. Change one thing not covered in the listing, and you have an unlisted product in your building full of people. And fourth, the accreditation scope matters. The accreditation scope is not for everything. They are authorized for a specific test method, specific standard edition, specific product categories. So if the product support cites a method outside their scope of work, that report has no authority. And fifth, counterfeits are on your market. People will always look for the cheaper alternative. And remember, the mark or the labeling is the start. Always check the serial number, the database, and any doubt, do not approve and always verify. And finally, you are the last line. It's your responsibility. Everything we covered today, the fire science, the testing, the standards, the certification hierarchy, the global accreditation system, it all ends with one person standing in front of a product, a report, or a layout, and making a decision. Approval or rejection, there's nothing in between. And that person is you. And a fire doesn't care about paperwork or approval or listing or certificate. It will find the weakest point and go through it. Make sure the weak point is not your signature or approval. And that is everything for now. We start from the foundation, how fire behave, how materials are tested, what those results actually mean. We built up those standards, certifications, reports, and the global system behind every mark you see in this field. And if you want to take one thing from today, just verify everything. Because behind every approval is a building full of people who trusted you. Think of these people as your family, your closest people, your parents, or even your kids. Because in this field, our ignorant mistakes can cost lives. Thank you so much for listening, and for any further inquiries, my contact details are on the screen. And if you found this useful, share it with someone in the field who needs it. Any feedback is welcome. It helps make the next one better. And I will see you in the next one.